your review. This is pretty much a mirror of the test tomorrow. I will provide you with a few things for the test. Thing one will be the density equation. Thing two, I will provide you with the kind of layout of the KHDA, that whole thing. So the metric conversion, I will provide you with that. I will provide you with the percent error formula as well. And then as we're going through here, if I pick up on other stuff that you think you're going to need, I will provide. Now, this is not the densities of the things that you're going to be working with tomorrow. You'll have different densities, but these will be given to you. You're not required to know these, okay? So, sorry. As we go through here, I am going to be grading on sig figs in the, but that'll be part of the answer. So one of your problems will ask about density. I'm giving you mass here, and I'm giving you volume here. This is a 2 sig fig number. This is a 4 sig fig number. So you should have 2 sig figs in your answer. This 0 is at the beginning of a number with a decimal. So zeros at the beginning of a number are not significant. So I only have 2 sig figs here in my answer. I'm writing my units out here, and I'm transferring them over here. Nothing cancels, so they both go over here. So I will also be grading you on your units as well. And you practice that in your lab. And I can hand those back. The ones that I've received. And then I've got these labs to hand back too. So we need to do that before you guys head out. I'm going to put these on Madison's desk because she will be good to remind me to get those handed out. Okay. All right. Any questions on problem number 1? All right. Problem number 2. Scientific notation. When we are doing scientific notation, we are, let me see if I can get this just a scunch bigger here. I've got too many things in the way. There we go. There, that's better. When we're doing scientific notation, you look at your number here. You're going to slide the decimal point over until the number that remains is between 1 and 9. So when I slid this over, it went 3 places, and I slid it this direction. So I'm going to multiply this by 10 to the negative 3. Here, I can imagine a decimal at the end. I'm going to slide it 1, 2, 3, 4, 5 spaces. I went this direction this time, so this is going to be a positive value here. So I have 1.208 times 10 to the 5th. Any questions about that? Anything that doesn't make sense? Here, I have a 5 sig fig number multiplied by a 2 sig fig number. So my answer should be 2 significant figures. If I were to go and put a decimal point here, how many sig figs would I have? 5. But I only want a 2 sig fig number, so I'm going to have zeros here. Here I have a 1 sig fig number. Remember, this stuff over here doesn't count as far as significant figures. We still need to put it in our calculator, but it doesn't count for significant figures. So I have a 1 sig fig and a 3 sig fig, so I should have 1 sig fig in my answer. When I calculate this out, I'm going to round that to 1 significant figure. This 0 is not significant, so I'm still okay with the number of sig figs, or I could write it in scientific notation. Either one is acceptable in this case. When we are adding or subtracting, remember that that comes down to place value. I'm at the 10th place here. I'm at the thousandths here, and I'm at the hundredths here. So my answer could only be to the tenths. Everybody okay with those? All right. We also have talked about the accuracy and precision. So when we talk about accuracy, accuracy is based on a standard accepted value. If you are close to that standard, then you're accurate. Precision then is how close your measurements are to one another. So when we did the density lab, if you remember that, okay, you had a beaker and you gave, you calculated the density for that. So let's say for your beaker, when you calculated your densities came out to 0.840, 0.841, and 0.842. These would have been very precise because they're right in line with one another. They're very close, but the accepted density was 1 gram per milliliter. So even though they're precise, they were not accurate. Good? Makes sense? So here I had you do a percent error problem with the measured density. So you measured your density here as 0.151. So they say that that's your measured. And then from the chart up here, you were able to get the 0.43. So that is the accepted density. Now, when you are putting this in your calculator and you are calculating percent error, always do this top line and hit the equals key after that. Then hit your divide key, because this line means divide, and then put this number in, and then hit equals, multiply it by 100, and then hit equals again. The problem is that if you do this, if you don't hit that equal sign at the end here, it'll follow our order of operations, and you'll end up getting the wrong answer.
So in this packet, it says to do accepted minus measured over accepted, but then the key said to do measured minus accepted over accepted.
It doesn't matter because it's absolute value. So you're still going to get the same top number. So if you do 0.53 on your calculator, sorry, 0.51 minus 0.43, that's 0.08. If I do 0.43 minus 0.51, it's a negative 0.08. So it doesn't matter which one you put in because it's absolute value. You're going to ignore the negative sign anyway. You just need to make sure that you also have the accepted on the bottom. Does that make sense? Yeah, I mean it. And sometimes you'll see it written one way and sometimes you'll see it written the other, and it doesn't matter which way it's written because you're going to end up with the same value either way. Is that making sense? Why? Okay. If we didn't have these absolute value marks here, then, obviously that would have, it would make a difference at that point, but because they're here, it doesn't matter. So typically I report the percent error to either the tenths or the hundredths place. So I'll take it however you want to give it to me, as long as it's at least to the ones. But usually it's reported back to the tens. Okay, or hundreds. Any questions? Any other questions on percent error? All right. Low percent error means that you have that you're good in terms of accuracy. So the lower the percent error, the better it is. If you can get it to 0, that means that you had a perfect experiment. In college chemistry, a lot of times with our labs, we had to perform this at the end of our experiment, And if we weren't 5% or less, we had to redo the whole lab. So that's kind of a standard that they go by. All right, so here we're going to convert the following using the metric system. We have 2.5, and that is kilograms. I'm going to give you this chart. This is your base unit here. I'm going to give you this chart tomorrow for the test, so you don't have to have it memorized. You just simply need to know how to use it. So here I'm going from kilograms to grams. My decimal is right here. I'm going to count how many spaces I need to go. I need to go 1, 2, 3 to get to grams. So I'm going to move my decimal 1, 2, 3, and I'm going to fill in those loops. And that's how I got 2,500. And now I'm going to go to milligrams. So I'm going to go 3 more spaces. So I'm going to go 1, 2, 3, and I fill those in with zeros. I've got to have these zeros in here. Why? Placeholders, yep. All right, questions? Keep trying to use that mouse. Okay, so we've got a graph here. When we look at graphs, remember, you probably talked about like which thing goes on which axis. The way I remember what goes where is something called dry mix. You're like, what? It works for me. So what this stands for is this is dependent. This is responding. And it goes on the y-axis. This is manipulated. This is independent. And it goes on the x-axis. So how do we figure out what that is? So which one of these is dependent upon the other? Well, my amount of my bill, okay, is dependent upon the number of texts. So in this case, this graph is wrong because back in the day, they used to charge you per text. You know, crazy, right? Now it's kind of unlimited and nobody ever gets charged for extra. But it used to be that your amount of your bill was determined by how many texts you made. So if that's the case, the amount of the bill depends on the text. These axes should be reversed because this is your dependent variable in this case. And your independent or manipulated variable is here. You do this, this responds. Does that make sense? Does it make sense which axis this should be on then as well? Okay. All right. Then this is very similar to what we did in with the dice. You had the mass of that dice. Then you had the graduated cylinder before you put the dice in it and then after. And the difference then is the volume of the object. Okay. So this gives me the volume of my object. I'm going to report that back in milliliters because these were in milliliters. This is going to be to the singles place because when I subtract, I'm taking into account my sig figs. Then I'm going to come down here. They want to know the density. So the density of the metal is here. So that's 95 over the 12 that we calculated here. I have a 2 sig fig divided by 2 sig figs. My answer should be 2 sig figs. And then I'm going to bring my units over. So this is going to be grams per milliliter over here. All right, any questions? All right. So I'm going to take this value and I'm going to go over here and try to find it in my table. So here is the value. It matches up with iron. So I'm able to identify what material that is. Good? Making sense? All right. Oh, shoot. They want to know what densities each liquid is. Well, remember density, and I'll give you this formula tomorrow. Density is mass over volume. So what I do is I pick a point on the line. It doesn't matter what point I pick as long as I'm on the right line. So this is my liquid A. If I pick this point right here, my mass is 2. My volume is 4. So I do 2 over 4 and I get 0.5 for my density. Do the same thing for liquid B. If I just pick a point, so here's the 2 and 2. So right there, 2 and 2. That ends up being 1. And then for the last one here, I have 5 here and 2 here. 5 divided by 2 is 2.5. If I wanted to keep proper sig figs, that would be 3 then. If you have 6 grams of liquid A, how many milliliters would that be? Well, I'm going to find 6 on here. I'm going to go up and then, no, I need to find 6 grams, sorry. So 6 grams is here. So I go across and then I go down and that's where I get the 12 from. You could also use this density value here and calculate it if you wanted. And then liquid C, the mass is 10, I'm sorry, the volume is 10 milliliters. So let's see here, that might go up above the graph. So 10, oh, no, it doesn't. So right there on the graph, and then I go over here, and that's where it would be, so that's 25. If it went off, I would need to use this formula and be able to figure that out. So there's a couple of different ways you can do it. All right. This one messed up a few people on the quiz the other day. Remember, you're putting down your sure values. So you're sure about this one. You're sure about the 6. And then you're estimating this last value. So if you would have had 11.62, that would have been acceptable because that last digit is an estimate. What is the purpose of significant figures? They are used to communicate the precision of your measurement device. So when you're doing that, you're communicating to people how good the measurement device was. Did it look like this where it had multiple divisions between? Did it look like this where it didn't? It just went 12 and then 13 over here. So by reflecting that in your answer, you're telling them how good your equipment is. Looks like I need to put that down. 1 centimeter cubed equals 1 milliliter. So I'll have that down on your sheet. Here you're using dimensional analysis. So you are taking 55 miles per 1 hour. We're converting miles, and I will have conversion factors like this on your paper. I gave you that orange sheet, so I expected you to have that, like to be able to do your homework with. But anything other than within the metric system, I will give you on the paper. I don't expect you to know something like this. That's not an expectation of this course. This I expect you to be able to do because that's within the metric system. All right. So I want to get rid of miles. So I put miles on the bottom. I'm going into kilometers. Again, I'm going to give you this conversion factor. Then I'm going to take miles or the kilometers and convert that into meters. So this is going to give me my meters per hour. If I wanted to stick with sig figs, I would need 2 sig figs. So this is how I would write it to maintain those significant figures. And then lastly, we had grams per liter. We want to convert grams into kilograms. I'm not going to give you this conversion factor. You must be able to get that on your own and then put it into the dimensional analysis and work through it. This is the test. If you can do this stuff, you should be set for tomorrow. You need to bring in a scientific calculator that you are comfortable working with. I have permission slips for you to get scientific calculator from me if you need it. So make sure that you're taking advantage of that if you need one, okay? All right. Any other questions about the